In this video, I wanted to work on the elimination method or addition method. Addition method. All right, so with this one, the addition method, what you're going to try to do is adjust the two equations so that the numbers out in front of either x or y, so that they are opposites of one another. And then you'll add the two equations and one of the variables will be eliminated. So what I'm asking on number one is, what if I wanted the y variable to go away? If I wanted the y variable to go away, I'd need the numbers in front of the y to be one positive and one negative, but to be opposites, right? So looking at 2 and 4, I could make those into both 8s, 1 8, 1 negative 8, or both 4s, 1 4 and 1 negative 4, that type of thing. So what I would do is I would multiply just the top equation by 2. And when I distribute that 2 all the way through, I'd get 6x plus 4y equals 16. Now, multiplying through by 2 doesn't really change the equation. So if the two equations look like that to start with, when I multiply the one equation by 2, it still stays right where it was. Okay. Now I'm going to bring the other equation along. And you see how now these are opposite? So if I were to add at that point, I would get 11x equals 17. Now, we're really not trying to solve these, but I just want you to kind of see the idea that we're getting at. Can't get it to erase. Okay, there we go. All right. Now, what I'm asking on part B is, what if instead of eliminating the y, I wanted to eliminate the x? Looking at the x's. See how you could turn those into 15? You could multiply the top equation by 5, the bottom equation by 3. When you did that, you'd get a 15 on each of them. But you need one negative, so just throw a negative on one of them. So now that's going to be 15x plus 10y equals 40, and then negative 15x plus 12y equals negative 3. So we got it ready. See, here the y's cancel, here the x's cancel when we add the two. So we would get 22y equals 37, and we could go from there, but we're just not being asked to go any further. We're just trying to figure out like how to think about things, how to plan how you're going to approach the problems. Okay. All right, so let's look at number 2. Darn it, I hate it when it moves like that. Well, just erase that out of there. Okay, on question number 2, it's asking us a different question. It's asking us to plan ahead, to look at the two equations and think about which variable, x or y, would be easier to eliminate using the addition method. I think y would be easier in the first equation. I guess I don't need to say in the first equation, just y. Because we just need to multiply by the first equation by 4 on both sides. Okay. All right, so now we're just being asked to try it out. So let me jot down my two equations. And I'm going to multiply that first equation through by 4. When I do, that first equation becomes 16x plus 4y equals 36. The bottom equation is 3x minus 4y equals 2. So I wind up with 19x, the y's are gone like I planned for them to be, equals 38. And so when I divide by 19 on both sides, I find out that x equals 2. Okay. All right, I need to pick one of the two equations and plug the 2 in. I'm just going to pick the first equation since everything's positive, and then put a 2 right there where x is. So I'd have 8 plus y is 9. When I take away 8 from both sides, I'd get y equals 1. So I'm thinking the answer should be an x of 2 and a y of 1. Okay, I use the top equation to find that. So if you're going to check it, use the bottom equation to check and see 6 minus 4 does equal 2. So I actually know I'm right at that point. Okay, so that's the basics of the elimination method. All right, let me do one more, and then I think I'll stop it and finish the rest later. No, maybe I'll do 2 more. Just kind of look them over a little bit. Yeah. All right, so on question number 3, the y's are already opposites. So I don't have to tweak these equations. I can come right in and add, and I'd get 2x, the y's cancel, equals negative 8. So x would be negative 4. So I could take either equation. I'm taking the top one because of the x and y both being positive. I'm replacing x with negative 4 and then solving that equation. So I'm going to add 4 to both sides. I get y equals 2. And so I get the equation the ordered pair negative 4, 2. For my check, I can plug it into x minus y equals negative 6. Negative 4 minus 2, sure enough, equals negative 6. So actually that tells me I'm for sure correct once I've done that. Okay. All right, I think I can do a couple more. Just getting tired here. All right, so before you jump right in, you look at it. I think it's easier to get the y by itself. So I think I'll come in and multiply that second equation through by 5. When it gets distributed to that second term, it'll be minus 5y, and I had a plus 5y, so that's good. That'll make the y's cancel out. So I just brought the first equation over, but I'm now taking 5 times the 2x, which would be 10x, minus the 5 times the y, equals 5 times negative 6. Okay, so when I do that, I get a 13x, and I get a negative 13 over here. Uh-oh. So weird. Something happened while I was right in the middle of it. Let's go back, see where I'm at. Okay, so I get a 13x equals a negative 13. So when I divide by 13, x equals negative 1. Okay, so I could take either equation to find the y. I'm just going to take that first equation because everything's positive, plug a negative 1 where the x is, and keep going, working it out using our Chapter 2 skills. Okay, so I'm going to add 3, which tells me that 5y has to be 20. So when I divide by 5, the y would be 4. So I get the ordered pair, negative 1, 4. I use the top equation, this equation, to find it. So my check would be take the -1 and put it in where x is, 4 in where y is in the second equation and see if it works. -2 minus 4 does equal -6. We know we're right. Okay. All right, let me keep going, see if I can finish this elimination. Actually, let me just stop for now. I'll do another one on this later.